Number 49, we have HK is equal to negative 5, 3 and a point on the graph XY equals 2, 9. So our standard form, f of x equals a times the quantity x minus h squared plus k. So we're going to let y equal f of x and then substitute everything we know. So y is f of x now, y is 9 over there, so 9 equals a, which we don't know yet, and then x here is this x, 2, minus h. H is negative 5 minus a negative 5, that's plus 5 squared, plus k, which is 3. Alright, so that's 7 squared is 49, so that's 49a plus 3. Solve that for a, you get 6 equals 49a, and we have a equals 6/49. Uh-oh. And they're giving us fractions. Nasty, huh? Nasty, nasty fractions. Alright. So, therefore, f of x is equal to, using the standard form once again, 6/49, that's a, times x minus h, which is negative 5, that's x minus negative 5, or x plus 5 squared, plus k, which is 3. And I'm writing small because I think I'm going to need the space to simplify this. Because of our nice little fraction here, 6/49. Expand the x plus 5 quantity squared, that gives you x squared plus 10x plus 25. In parentheses, plus 3. And then you can distribute that through the 6/49, so you get 6/49 x squared plus 60/49 x plus, and then you got 25 times 6, that's 150 over 49, and then plus 3. Alright. Now, if you multiply 3 by 49 over 49, you get 147/49. So, let me just, instead of rewriting this whole line again, I'll just point an arrow to what it equals with a common denominator. That's 147/49. Again, you multiply 3 by 49 over 49 to get that. Okay, now you add this with a common denominator to that, and we've got the final result, 6/49 x squared plus 60/49 x, and then when you add those two, you get 297/49. There she is. '51. Here we have HK equals 0, 1. And the point xy on the graph is 1, 0. Or a point on the graph is 1, 0. And then we have the standard form f of x equals a times the quantity x minus h squared plus k. So we'll let y equal f of x. And then we'll substitute everything we know. So y is f of x here, so y is 0 there. Using a sample point from the graph equals a, and then x is 1, minus h is 0, 1 minus 0 squared, plus k is 1. Wow, this is turning out to be simple. They're giving us a break after that last one, right? So this becomes 1a plus 1, or a plus 1. So subtract 1 from both sides, you get a equals negative 1. Alright, so therefore, f of x, using the standard form, is negative 1, or just put a negative sign in front of the parentheses, and you've got x minus h, which is 0, x minus 0 squared, plus k, which is 1. And this just becomes x squared, so it's negative x squared plus 1. And that's already in general form, so we're done. Number 53. For the following exercises, sketch a graph of the quadratic function and give the vertex, axis of symmetry, and intercepts. So it doesn't specify what intercepts. There is a y-intercept with these parabolas, so it's not just x-intercepts. Sometimes, you know, if it doesn't touch the x-axis, you're going to have just a y-intercept. Okay, so we'll keep that in mind. We have f of x equals x squared minus 2x. And I know you can just punch this into your graphing calculator or computer and get a picture right away. And maybe even if the intercepts and the vertex are nice integer, have nice integer coordinates, you know, you can read them right off the graph. I know that. Sometimes they won't be that nice. They won't be integers. But the point of this course is to teach you some algebra skills, right, that you're going to need for calculus. So let's try doing it that way. So and of course we'll use technology to confirm what we get. Let's try for x-intercept first. Okay, so we set this equal to 0. The x-intercepts are where it crosses the x-axis, if it does at all, and that's where y equals 0. Y equals this, right? Y equals f of x, or this. So you set that equal to 0. And then you solve for x. Alright, now, one thing you should not do here is divide both sides by x. Why? Because x may equal 0, in which case you're going to get something that's not going to work. Alright, so you may be missing something in your answer. So don't divide these by x. Alright, what you do to solve these is to factor. In other words, don't move this to that side and then divide both sides by x. Alright, or divide both sides by x right off the bat. Okay, so instead of that, you factor an x out of there, common factor. And now you have this times this equals 0. So I was taught the principle of zero products. where if something times something equals 0, then this equals 0 or that equals 0. So that means x equals 0 or x minus 2 equals 0. And then you solve each of those separately. Well, this is already solved. So x equals 0 or 2. Alright. So we have two x-intercepts, 0, 0, and I know y equals 0 at the x-intercept, obviously, right? And 2, 0. Okay. And let's not forget the y-intercept, which is pretty easy to calculate, so we may as well do that. So you just, for the y-intercept, that's when x equals 0, right? It crosses or it touches the y-axis, and all along the y-axis you have x equals 0. So just take f of 0 and plug it in, 0, 0, right? So it's 0. So we have the point 0, 0, which also happens to be one of the x-intercepts, alright? Okay, well, we've got the intercepts. How about the vertex? V. Call that V. Well, you can complete the square. We've got x squared minus 2x. And that's equal to, take half the coefficient of x. That would be -1, although the sign really doesn't matter because you're going to square that anyway. -1 squared is 1, and then you add and subtract 1. So you got x squared minus 2x plus 1 minus 1. So I'm adding 0. I'm going to group these the first three terms together. X squared minus 2x plus 1 using associativity. Alright. And this is always going to be a perfect square trinomial, so that's x minus 1, quantity squared minus 1. So now we can read the vertex right off of the standard form. That's 1, -1. There's our vertex. 1, -1. So obviously the axis of symmetry is x equals 1. I'll put that over here. Okay, so now we've got all the information they asked for except for their graph, which now we can use our technology, and I put it on my machine, and here is what I came up with. Number 55, we have f of x is x squared minus 5x minus 6. So let's find out what the x-intercepts are. So we'll set the function equal to 0. Solve for x. Alright, now when you solve these, of course you could complete the square or you could use a quadratic formula, but if you can factor, that's the easiest way. So you can't always factor, but completing the square and quadratic formula always work. But this one can be factored. This is x plus 1 and x minus 6. So this times this equals 0, so that means that x plus 1 equals 0, or x minus 6 equals 0. So x equals -1 or x equals 6. Alright, so we have two x-intercepts, -1, 0, and 6, 0. Okay, there's also a y-intercept, which I noticed isn't always in the answer section in the book. Alright, but there is a y-intercept on these all the time. So, and they didn't specify which intercept, so we should do this. Alright, this is f of 0. Plug in 0, 0. You end up with just -6. So f of 0 equals -6. Alright, so the y-intercept is 0, -6. And now for the vertex. Call it v. We'll complete the square on x squared minus 5x minus 6. So x squared minus 5x minus 6, that equals, grouping the x squared and x terms, x squared minus 5x minus 6 using associativity, grouping those together. And this is x squared minus 5x. Take half the coefficient of x, that's 5 halves. Square that, that's 25 fourths. And then add and subtract 25 fourths. Minus 25 fourths minus 6. So this is x squared minus 5x plus 25 fourths minus 25 fourths, and then 6 can be written as 24 fourths. Alright. So this is a perfect square trinomial. That's x minus 5 over 2. You can take, to get the 5 over 2, you could take the square root of that term, or just take half of that term. So 5 over 2, x minus 5, and it's minus because of that minus there. And you get squared. And then subtract those two together and you get 49 fourths, minus a 49 fourths. So we have 5 halves for a negative 49 fourths as the vertex. Now this is something that you probably, I don't know, unless they've made advances in graphing calculators since I had one, or since I'm used one, you're probably not going to be able to read that directly off the graph. It'll be a decimal approximation. Alright, so you should always know how to do this using algebra. And the axis of symmetry, I'll call it AS, is x equals 5 halves. That's the x-coordinate of the vertex. Okay, so there's the information. And now for the graph. Here we go. Number 57, we have f of x is equal to negative 2x squared plus 5x minus 8. You'll note that the leading coefficient is negative 2. Since it's negative, the graph will open, or the parabola will open downward. Alright, so why do I mention that? Because when you graph it, and if you get a graph that opens upward, you entered it incorrectly, okay? Alright, let's go for the x-intercepts, if any. So on this one, I don't think we can factor this, so we're going to use a quadratic formula. X equals, what you do is you set that equal to 0, which I did not write. And then I use a quadratic formula to solve for x. So that's once again, negative b plus or minus square root of b squared minus 4ac. Make sure that's all under the radical there, all over 2a. So we've got a negative 5 plus or minus square root of 5 squared minus 4 times negative 2 times negative 8 all over 2 times negative 2. So that's negative 5 plus or minus the square root of 25 minus 64 under the radical over negative 4. So this turns out to be negative 39. I'll just put an arrow there. That is negative 39. Okay. So what we get then is we're going to get an imaginary number, negative 5 plus or minus square root of 39i over negative 4. So we'll write it in standard form. That's going to be negative 5 over negative 4, or 5/4. Plus or minus, and then the 4 here is negative, right? So you could put a negative here. Negative square root of 39 over 4i. But really this isn't necessary. It's because if it is negative, when you use the plus, that becomes a minus. Plus a minus becomes a minus. And if you use the negative here, negative of a negative is positive, so you're going to get minus plus. It's basically the same as plus or minus in this problem. So it's 5/4 plus or minus square root of 39/4. So that negative sign there really doesn't add any more information. Alright, so we can get rid of it. Because the plus or minus just takes care of, there's only two solutions, right? The plus or the minus, and it's going to be a plus or minus whether you keep that there or you don't. Alright, so we can dispense with that. So that's our two x-intercepts. Well, now these are not real numbers, right? These two are not real numbers because of the I. So this parabola will not touch the x-axis. So there are no x-intercepts, okay? When we graph it, there aren't any, alright? So you won't see them. So we'll just say there are no intercepts, no x-intercepts. How about the y-intercept? That's f of 0 equals negative 8. That's always easy to compute. So we have 0, negative 8 as a y-intercept. Alright, so for the vertex, we'll complete the square. And or you could use negative b over 2a and f of negative b over 2a to get the vertex, but I'm going to complete the square, so for that I need some space. So let me erase. Okay, here we go. So the vertex v, we're going to complete the square on negative 2x squared plus 5x minus 8. So we're going to group the x squared and x terms, negative 2x squared plus 5x, using associativity, like that. Now we factor out the leading coefficient, negative 2. That leaves you with x squared minus 5/2 x. And if you don't believe that, just multiply that back through. Negative 2 times negative 5/2 x. Well, the 2 cancels that 2 and the negatives become positive, so you get positive 5x, as it should be. And then we've got minus 8. So we got negative 2 x squared minus 5/2 x, and then you take half the coefficient of x. 1/2 times 5/2 is 5/4, and then you square that. That's 25/16. And then you add and subtract 25/16 inside the parentheses, plus 25/16 minus 25/16 minus 8. Alright. Now what I want to do is bring that negative 25/16 out, but before I do that I have to multiply first by negative 2, because the negative 2 is multiplying everything in here in the parentheses. So you multiply first. Negative 2 times negative 25/16 is, well, the 2 will cancel with a 16. That'll give you a plus 25/8. Alright, so you've got in the parentheses, now what you have left is this. And you can bring out that 25/8, becomes positive 25/8 minus 8. Alright. So in the parentheses we have a perfect square trinomial. This is x, and it's going to be a minus because of that minus, and then take either the square root of that, which is 5/4, or half of that, which is 5/4. And oh, that's going to turn out to be a minus out here. Okay, so multiply the 8 by 8/8 to get a common denominator of 8, so that becomes 64/8. So it's going to be 25/8 minus 64/8, which equals a negative 39/8. Alright, so the vertex is 5/4 and negative 39/8. And the axis of symmetry is x equals 5/4. Alright, so there we have it. Now for the graph. And we expect this to open downward, and we also don't expect it to touch the x-axis. And that's exactly what we have here.